Welcome back. Okay, today we are cracking open the user manual for the Delta VFD EL-W series. Now, if you've ever stared at a variable frequency drive manual and just felt completely overwhelmed by, endless pages of dense tables and technical jargon, well, take a breath, because this explainer is exactly what you need. We're going to take all that raw technical data and transform it into a really clear, actionable roadmap. By the end of this, you're going to know exactly how to navigate this system and get your drive up and running without the headache. Let's dive in. So, here's our game plan for today. We're going to start by navigating parameter groups, set up our core basic parameters, wire up our input functions, tackle the basics of multi-pump control, and then finish up by fine-tuning the whole system. All right, part 1. Navigating parameter groups, the drive's filing system. Let's see how this thing is actually organized. To really ground this, let's take a look at the digital keypad itself. Think of this as your primary command center. And what's actually brilliant here is how the VFD EL-W displays exactly what you need right there on the screen. Basically, the left side shows your target values, stuff like your set frequency or your PID settings, and the right side, that gives you your actual physical feedback in real time. Plus, you've got these really clear LED indicators for run, stop, forward, and reverse. It literally takes all the guesswork out of what your drive is doing.
And to configure that command center, get this, you're only dealing with 11 parameter groups. Just 11. They start at group 0 for user parameters and go up to group 10 for your PID and multi-pump control. The big takeaway here, you absolutely do not need to memorize the entire manual. It's like a giant filing cabinet. You just need to know which of those 11 drawers to open to find the setting you want.
Moving right along to part 2, core basic parameters, setting the foundation. Let's open that first drawer.
Okay, group 01. This is where we lay the bedrock for the motor. Parameter 01.00 sets your max operation frequency, and 01.01 sets the motor's rated frequency. Depending on where you are in the world, these default to either 50 or 60 Hz. Then you've got parameter 01.02, which is your motor's rated voltage. This is super critical. If you're using a 230-volt model, this ranges from 0.1 to 255 volts. But if you're running the beefier 460-volt models, that scales all the way up to 510 volts. Guys, you absolutely must ensure these numbers match your motor's physical nameplate before you do anything else.
Once those basics are punched in, the manual tells us it's time for a trial run. When you power it on, the keypad usually defaults to 60 Hz. The manual actually says, hey, let's play it safe. So you drop that down to 5 Hz using the keypad and hit run. What we're doing here is verifying the motor spinning in the right direction. When your output terminals U, V, and W are connected, that forward LED should light up and the motor should spin forward smoothly. No weird abnormal noises. If it's spinning backwards, no big deal. Just power it down safely and swap any 2 of those motor terminal connections. Boom, baseline verified.
All right, part 3, wiring input and output functions. Taking control. Let's look at how we talk to the drive from the outside. So out of the box, the drive listens to the digital keypad. But what if you're an industrial plant and you need to control this thing from a remote PLC or a switch way across the room? That is where group 2 comes in. Parameter 02.01 is essentially your master toggle switch. It lets you shift the control authority right off the physical keypad and hand the keys over to your external EMI terminals.
Now, if you do hand over that authority, you're going to need group 04. Specifically, parameter 04.04. This is a game changer because it configures those external terminals to match the actual wiring in your facility. You can set it up for a classic 2-wire control using terminals MI1 and MI2 for your basic run, stop, and forward reverse. Or, if your safety protocols demand it, you can bump it up to a 3-wire setup using MI1, 2, and 3. It's incredibly adaptable.
Which brings us to part 4, multi-pump control basics. The crown jewel. Let's get into group 10. When you've got a whole system of pumps working together, somebody has to be in charge, right? Parameter 10.36 establishes that chain of command. It assigns a multi-pump ID. If you set it to 1, congratulations, that drive is now the master pump. It handles the baseline load and crunches all the constant pressure math. If you assign settings 2 through 4, those become your slave pumps. They basically just sit on standby, waiting for the master to tag them in when things get heavy.
And the way this actually works is so cool. Picture the wiring for a constant pressure setup. You've got a pressure sensor out there in the pipe, and it's sending a 4 to 20 milliamp analog feedback signal straight into the drive's analog input terminals. The drive reads that real-world pressure, compares it to your target, and instantly dials the motor speed up or down. It keeps the water pressure absolutely perfect, whether one person turns on a faucet or 50 people do.
To actually get that master pump regulating like that, you just follow a simple sequence. First, you set your PID target point in parameters 10.00 and 10.01. Next, you dial in your P, I, and D gains, that's parameters 10.02 through 10.04, so the drive reacts smoothly without bouncing all over the place. Third, jump back to Group 1 to set your acceleration and deceleration times for smooth starts. And finally, pop into Group 0, parameters 00.04, to make sure the keypad is actively displaying your PID feedback.
Okay, last section. Part 5. Fine-tuning the pump system, maximizing efficiency. Let's make this setup smart. How your multi-pump system behaves over the long haul comes down to parameter 10.35. You've got two main modes here. Mode 01 is fixed time circulation. This is awesome because, after a set amount of time, the master and slave pumps will literally trade jobs. It's perfect for balancing out wear and tear across your hardware. Mode 02, though, is fixed quantity control. This is all about maintaining constant pressure during crazy demand spikes. If the master is giving it everything it's got and pressure is still dropping, it automatically kicks on a slave pump to handle the rush.
Now, if you do go with Mode 1 to save your equipment, the default swap time is 60 minutes. You'll find that in parameter 10.37. So out of the box, every hour on the hour, the system intelligently tags in a fresh pump. But, every facility is different, so you can tweak that to be as short as 1 minute or as long as 65,000 minutes.
And just like that, we've gone from staring at a blank, intimidating screen to really understanding the guts of a fully automated multi-pump array, all because we knew which of those 11 parameter drawers to open. So here's my question for you. How are you going to configure these parameter groups to perfectly balance the constant pressure demands of your own facility? Grab that manual, check those nameplates, and start putting this into practice. Thanks for hanging out with me for this explainer. Keep learning, and I will catch you next time.